Welcome to the world of Robert Sorby, the world's premier manufacturer of wood turning tools. This video explores the fascinating craft of thread cutting by hand. This is a centuries-old practice. It is used where it is necessary to assemble or disassemble a workpiece. Hand thread cutting is a craft surrounded in anecdotal stories which speak of it being difficult to master, when in reality it is not. In this video, you will be taken through all the processes involved in creating perfect threads on turned work. We will also create 3 projects. One, a simple threaded box made in lignum vitae. The second, a Finial box from Cocobolo with threaded boxwood inserts. And finally a mallet from boxwood and lignum vitae with an interchangeable head. First, let's look at the tools required to produce matching pairs of threads. To cut threads, there are 2 cutters. One is the external, which has teeth on the front of the blade. The other is the internal cutter. This has teeth orientated on the left-hand side of the blade. Thread cutters are available in a range of sizes to suit different projects and different materials. Traditionally, engineers' thread chasers were designed for working with metal. Recognizing this, Robert Sorby have developed a series of thread cutters with a unique helix angle and profile. This makes them not only easier to use, but also ensures a fine and consistent thread time after time in wood and similar materials. Thread cutters are differentiated by the number of threads per inch. Internal and external cutters are identical in both form and pitch. Their teeth align and match perfectly. The teeth are offset from the vertical, allowing the cutters to form the thread as they are traversed across the surface of the work. Even using such enhanced cutters, not all materials can be successfully threaded. Threading should only be attempted on dense, hard and stable woods, for example, boxwood, lignum vitae, violet rosewood, and many close-grained exotics. You must be sure to use dry, well-seasoned wood, as any distortion occurring later will prevent the 2 threads from matching perfectly. In addition to wood, threads can also be cut in such synthetic materials as alternative ivory. As part of the Robert Sorby thread cutting system, there is also a relief cutting tool. This simplifies the task of producing the necessary recess at the end of an internal threaded area. Robert Sorby have also designed a unique thread and sizing gauge which takes the guesswork out of dimensioning your workpiece prior to thread cutting. It enables you to calculate the differential between internal and external threads and is calibrated to suit 10, 16 or 20 threads per inch. This is done by means of a preset anvil which is stamped with numbers corresponding to the size of thread cutter being used. There is also an unmarked anvil which enables sizing before creating a push fit. Together, these tools make a comprehensive package designed to take the mystique out of cutting threads by hand. This section view clearly shows how the external and internal threads fit together. Any inaccuracy between the two will leave the fit either too tight or too loose. To practice making a thread, we need a dense piece of wood smoothed down to a cylinder. The wood must be dense, otherwise fractured threads will ensue, as shown clearly on the left side of this piece. You will see that the thread on the right is out of shape. This has resulted from the tool not being traversed at an even rate. It is often known as a drunken thread. The thread on this smaller section is uniformly cut. This is what we are seeking to achieve. When these are viewed together, the difference between the correct and incorrect thread is easy to see. Now let's cut a thread. First of all, ensure your tool rest is smooth. We need an appropriate piece of wood to practice on. Here we are using boxwood. It is one of the easiest woods to thread and thus makes for an excellent practice piece. After the boxwood has been roughed down, round off the corner of the cylinder with a spindle gouge. This is important because a sharp corner will impede the clean striking of a thread. Once prepared, we can commence using a thread cutter. Before doing so, we need to master the cutting action of the tool. As with most things, there is a very definite technique involved. The technique is the same for both internal and external thread cutting. It is necessary to develop a movement as indicated in this diagram. The critical elements of this action are the progressive lead into the strike point, the parallel traverse, and the quick withdrawal. First of all, cut the external thread. Set the rest so that it's just above centre. Position the thread cutter with the blade flat on the rest and trail the tool down so that it will cut on or just below centre. Note the circular motion. A low speed is necessary. In this instance, the lathe is running at 250 RPM. A variable speed lathe does help, but it is not essential. Place the tool on the rest and practice the cutting action. The speed of the traverse will vary according to the size of cutter. A fine thread will require a slower traverse. As with a scraper, the handle is lifted slightly and the teeth are brought into contact with the wood as the tool is being smoothly traversed across the spigot. Remember, be positive and be firm. Relocate the cutter teeth into the partly formed groove, lifting the handle fractionally with each successive pass. It is better to take a number of light cuts rather than one or two very aggressive ones. You can now see how the thread is produced, but there is not a full form on the left. This will prevent the two parts threading together. To avoid this, you should cut a recess or relief at the end of the thread area prior to finishing the thread. This enables the cutter to be pulled away but still form a uniform depth of thread. A parting tool is ideal for this. Having cut the recess, continue with the uniform thread. If we slow the lathe down, you can see the cut clearly. Now that we have an external thread, we can look at an internal one. To start with, we need to hollow out a piece of wood. A spindle gouge makes light work of this. It is important not to make the wool too thin, as we are going to remove some wood when cutting the thread. Ensure the inside and outside walls are parallel. To cut the recess, present the relief tool horizontal to the workpiece so that it cuts on centre, and gently move the tool to the left so that it cuts a 3/16 or 5mm recess. It is a good idea to round off the edge so that when the cutter is guided in, the teeth do not catch on the corner. To cut an internal thread, start the lathe at a suitable speed. Position the tool so that it is horizontal and cuts on or just above centre. Practice the motion and strike the first thread. Remember, be positive and be firm. Once the initial thread is struck, a few gentle passes over the top will form the thread. We have seen how both internal and external threads are cut, but these have not been produced as a matching pair. In order to produce two sections that fit together correctly, we can make use of the unique Robert Sorby thread and sizing gauge. A new piece of boxwood has already been hollowed. The recess has been cut and is ready for threading, but first of all, let's measure it. As we are planning to use a 16 thread per inch cutter, we have to align the anvil using the appropriate number 16 setting. You can see that this automatically allows for the variance between the internal and external threads. Now measure the opening and remember to lock the slide arms in position by tightening both locking knobs. Now for threading. Create the external section and dimension the spigot until it corresponds to the gauge setting. The initial part of the spigot is being cut with a parting tool, creating a parallel section on which to form the thread. A beading and parting tool is used to extend the spigot. Remember to round off the sharp corner. Next, we cut a recess at the end of the spigot prior to threading. With the lathe running at a low speed, cut a thread on the spigot. By using the gauge, we have taken all the guesswork out of matching the two parts. They will marry up with little or no adjustment. You can see we were successful first time, but it is important to practice threading as much as possible before you attempt your first threaded project. Some leading exponents advocate the use of a tool support for thread cutting. The tool support that has traditionally been used comprises a steel bar that has a hook formed on one end. By placing this support on the lathe tool rest, it can be used with a number of different turning tools. The tool itself is placed against the hooked end of the support, and the tool and support are moved as one. This movement of both tool and support helps to give more control to the cutting tool than may be possible by just extending unsupported over the lathe tool rest. The tool support may be used with 3 different tools, all involved in the production of internal threads. Firstly, in conjunction with a curved scraper. Now the relief cutting tool, as it is used to true up the base and the side of the recess, and then creates a recessed area at the end of the section that we propose to thread. The recess this tool produces forms a safety zone that allows us to remove the thread cutting tool before it strikes against the base of the workpiece. With no safety zone, any thread still within the cutting tool will be immediately stripped off. And finally, the internal threading tool is used in conjunction with the support. The cutter and support move as one to maximise total control. The cutting action used when making the thread involves several key points. At all times, when in contact with the wood, the cutting tool must be kept moving. The tool must be lifted clear when its front edge is within the safety zone. And a positive but not forceful action is best. With a little practice, it should be possible to cut a clean, crisp thread. Producing shavings rather than dust is a sure sign that a good thread is being formed. Before moving to the first of our projects, we need to look in more detail at how these particular cutters form a thread. These tools have been designed specifically by Robert Sorby for cutting threads in wood, and have a modified helix angle to help them produce consistent results over the widest range of wood diameters. A piece of boxwood has been prepared to receive an external thread. Again, at the end of the area we are to thread, there is a recess cut to act as a safety zone. This has been produced with a standard parting tool. By rubbing the heel of the cutter against the revolving workpiece, the helix angle we mentioned earlier pulls the tool across the wood, scoring it with the shape of the thread. Some styles of thread chaser have little or no helix angle. These engineering tools, used like this, would produce no thread, only concentric rings, as they were designed to clean up pre-machined threads. The starting point of the thread is on the softly rounded end of the spigot. The cutter is moved around slightly more with each pass onto the flat face. The thread is formed in many passes, each one extending the cut thread by 1 or 2 new grooves. Only when the thread is established along the whole length of the spigot is it possible to take full passes in one go. Once again, try to achieve fine shavings rather than dust. After trimming away the rounded start area at the front of the spigot, a reasonable clean external thread is left. Let's start putting some of these techniques into practice in our first project as we create this simple threaded box from lignum vitae. First of all, we have to create a cylinder. A 3/4 inch roughing out gouge is being used to quickly remove the waste wood. A quick smooth over with a skew chisel and we will be ready to start dimensioning the box. As you can see, the wood is very dense and oily and will thread well. A finish straight from the tool ought to be possible. True up the end with a beading and parting tool, and then create a dovetail spigot ready to hold in a chuck once the top is created. When the spigot has been formed, we can separate the top section from the base. The proportions in this case are 40% for the top and 60% for the bottom. This will produce a well-balanced box. In order to hold the bottom section in the chuck, we need to cut a further spigot. Having done that, fit the piece in your chuck and part through the midsection. A fluted parting tool is to be used for this. After removing the top, mount it in your chuck. Proceed to hollow out the lid. To do this, a 3/8 spindle gouge is being used. A micro bidan ensures the walls of the box are parallel. Once the hollow is formed, set the special Robert Soulby calipers to the 20 TPI position and dimension the internal diameter. The 20 corresponds to the TPI of the thread cutter to be used. Next, use the relief tool to form the recess in the bottom. Now we are ready to cut the thread. First, turn a small radius on the edge of the hollow. Practice the cyclical movement of the cutter to judge the speed of travel. When satisfied, strike the thread. Remember, be positive when striking the first thread and cut on or just above centre with the tool horizontal. Carry on in this fashion until the thread is fully formed. Once you are satisfied with your thread, remove the lid from the chuck and in its place mount the base. Use the special calipers to measure the spigot. A parting tool is being used to ensure the shoulder is square and clean. The parting tool creates the recess ready for the thread. Ensure your lathe is running at a low speed and cut the external thread. In this instance, the cutter is trailed and cuts on or just below centre. Now, try the lid to see if it fits. It does, but you will notice the two areas of light sapwood do not align correctly. So we have to remove a small amount from the end of the external thread. This causes the thread to start in a different place, and with minor modifications the pattern can be aligned. Further adjustment is required. Now it is fully aligned and seated correctly, and we can profile the outside of the box. The fluted parting tool can be used to create fine beads as a decoration. This versatile parting tool is also used to remove the spigot. Now we can hollow the inside. Refit the lid and add a little more decoration. This handy shear scraper finally smooths up the surface. The project is then parted off. A lidded box with threaded fitment. Our second project is this Finial box from Cocobolo. The Cocobolo itself proved too soft to thread, so we shall be using boxwood threaded inserts. It is a technique which can be used in conjunction with any wood which will not directly take a thread itself. First of all, we have to turn the Cocobolo down to a cylinder. Then smooth down with a skew chisel. A spigot is cut at both ends of the cylinder so that each end can be mounted in a chuck. Next, divide the top from the bottom. In this instance, the ratio is 2/3 bottom to 1/3 top. With the two sections separated, mount the top in the chuck and trim the face. You will notice a small raised section has been left on the Cocobolo. This will become the location point for the boxwood insert. Next, mount your piece of boxwood, which will become the insert. After roughing it down, create a recess so that it will nest with the Cocobolo. You will note that the face is being trued up with a 1/4 inch round skew. This is ideal for cleaning up corners and creating detail. After gluing the boxwood and Cocobolo together, profile the wastewood with a roughing gouge. The external section of the boxwood is now the same size as the Cocobolo. Using a 1/8 parting tool, we can define the shoulder at the back end of the spigot. A parallel spigot is turned with a beading and parting tool. The initial cut with the parting tool created the thread recess. The excess boxwood section is cut off and used for the base section of the box. With the waste parted off, we can now create our first thread. Remember, the thread cutter is trailed so that it cuts on or just below centre. In this instance, we have selected a 16 TPI cutter. Again, with your lathe at a low speed, strike and fully profile the thread. With the thread formed, set the caliper to the 16 TPI position and measure the spigot. This will be used to dimension the internal thread. Mount the base in your chuck and hollow the recess ready for accepting the boxwood insert. Note that the hollow is slightly wider than the raised section. That way we thread the boxwood, not the cocobolo. After hollowing, mount the spare boxwood section on your lathe and cut a spigot the same size as the hollow in the base. The two should fit perfectly. Finally, trim the shoulder. Fit and then glue the two sections together. When the glue has set, hollow the boxwood in preparation to create the internal thread. Regular checking with calipers, which we'd early set for the 16 TPI thread, is always advisable. Next, true up the sidewall with a round skew and complete the hollowing of the base. A beading and parting tool is excellent for hollowing. Now use the relief cutting tool to produce a recess. We can now proceed to form the thread. Always remember to cut on or just above centre with the tool horizontal. To prevent threads from breaking, apply a little paste wax before the final cuts. When the thread is fully formed, we can try to fit the top to the base. In this case, some modification is required on the underside of the lid, so it is necessary to remount. A mini shear scraper is used to smooth the curve. When we try the two sections again, they fit perfectly. Next, turn the finial on the lid with a spindle gouge. This shows how strong the threaded joint is. We are not using any tailstock support, and yet the lid remains rigid enough to turn. A small minaret followed by a ball are the first details. The next section is an elongated cove. And finally, the bottom cocobola section is blended into a finial with an OG curve. We can detail the boxwood sections with a few grooves using the round skew. Before going any further, sand and polish the finial. The finish here is friction polish. Once the top is polished, remove it and profile. Sand and polish the midsection of the base. Remove the base and rechuck it using a paper towel to prevent the chuck jaws from marking the wood. Check the workpiece is square and then remove the excess paper towel. Profile the bottom section of the base. Gentle cuts are required to avoid any damage to the project. The very bottom of the base is hollowed to ensure a stable seating on the table. A small bead is cut at the intersection of the foot and main body. It is then sanded and polished. That finishes off our finial box. Before going on to our final project, we will look at sharpening the thread cutters. Both internal and external cutters are sharpened in the same way, by rubbing a diamond hone across the flat surface. Never attempt to sharpen the teeth individually. Our third and final project is a mallet. The head is lignum vitae and is threaded on a boxwood shaft using a 10 TPI thread. This is a practical project in which the head may be removed when worn out and replaced. First of all, create a cylinder of boxwood which is long enough for the handle and the threaded spigot. A 3/4 inch roughing gouge is the ideal tool for this task. Since the thread has to secure the handle to the head tightly and safely, it has to fit well. We should plan for the thread to be around 4 inches long. Use a parting tool to delineate the shoulder from the spigot, but do not reduce the diameter too far or the spigot will be weakened. Once the dimensions have been established, remove any wastewood. The spigot needs to be parallel to ensure a tight fit. You will note the initial cut with the parting tool has also formed a thread recess. Once the spigot is parallel, set the calipers to 10 TPI and measure the spigot. We are now in a position to cut the thread. The 10 TPI cutter is ideally suited to larger projects. We are planning to cut a long thread, but the cutting action remains the same. Trail the tool and cut on or just below centre. The final thread is continuous and free from any defects. That is the handle complete. Next we rough down the lignum vitae, which is to become the head. It is a very dense wood and will take a little time to profile. Once that is done, cut a spigot in the end and fit it in your chuck. Having marked the size of the hole with calipers, hollow out the required depth. Initially this is done with a spindle gouge. Hollowing is completed with this Robert Sorby multi-tip tool. This is one of the most versatile turning tools around. The tip can be adjusted for straight hollowing or undercutting. Its flat surface means it sits squarely on the rest and quickly removes wood. It is very stable in use. Continue hollowing until you have reached the required depth. Ensure the walls are parallel and cut the recess with the relief cutting tool. At this depth, you will see the tool is almost at its operating limit. We can now cut the thread. The circular motion remains the same, irrespective of the depth of hole. Having formed the thread, we can assemble the mallet. An excellent fit. As we finish profiling the head and the handle, it is a good idea to bring up the tailstock. The striking head will have a nice smooth flowing curve. The handle will have a much more delicate curve. After initial profiling with the roughing gouge, a spindle gouge should be used to refine the shape. Having profiled the handle, finish the head. A flat top section ensures that the mallet will sit squarely on a table. The only finish being used is a quick sanding with fine abrasive. After sanding, part off. This project illustrates that threaded objects can be both aesthetically pleasing and practical. In this video, we have looked at the techniques in cutting threads by hand on turn projects. As with most aspects of turning, it is practice that makes perfect. A little patience will enable you to create pieces of beauty and function. We trust we have fired up your imagination sufficiently to encourage you to experiment for yourself. This is the latest in a series of wood turning videos produced by Robert Sorby. Focus on Decorating Techniques looks at different ways of decorating your pieces. It includes texturing, spiraling, chatter work, index work, and off-center turning. And Focus on Starting Out Wood Turning is a compendium of everything the beginner needs to know about wood turning, from selecting wood to the use and care of tools and project finishing. It is a must for anyone wanting a thorough grounding in the basics of wood turning. For further information on any Robert Soulby product, please contact us as shown on the screen. In addition, updated information can be accessed via our website.